the spring months of 1967, a critical review of the nation's manned spaceflight program was carried out. This re-evaluation had been initiated following the Apollo spacecraft accident at Launch Complex 34, Cape Kennedy, in January 1967. The causes were studied and corrective action was taken. Schedules were adjusted to accommodate the additional work involved. The tempo of Apollo activities picked up as the program recovered. At North American Aviation, Downey, California, astronauts Wally Schirra, Don Eisley, and Walter Cunningham were formally announced as the prime flight crew for the first Apollo mission. Their backup crew will be Tom Stafford, John Young, and Eugene Cernan. Both crews will train for an Earth orbital mission of up to 10 days duration. After exhaustive review and inspection, the spacecraft for the first manned mission entered modification and pre-flight checkout, which proceeded concurrently with additional ground qualification tests of new equipment. Unlike earlier command and service modules, the latest version of the Apollo spacecraft has new systems and features required for lunar missions, as well as for increased reliability and flight crew safety. Included in the new equipment are a docking system, which will allow the command and lunar modules to be mated in space. Also, a transfer tunnel, which will allow the flight crew to pass between modules. There is a new quick opening hatch. Similar to the Gemini spacecraft hatch, it provides for rapid egress by the crew in case of an emergency on the ground and for extravehicular operations in space. Covers and guards will protect display panels and wiring during both pre-flight checkout and flight. Fireproof containers have been incorporated for stowing potentially flammable materials, such as sleeping bags. Plumbing joints, originally comprising an inner Teflon sleeve and a soldered aluminum ferrule, have been reinforced with a split aluminum collar, which is bonded into place and secured with a snap ring. In the spacecraft, the reinforced joints will help prevent damage to plumbing. In addition to these and other changes, spacecraft preparation was continuing at the end of June, pointing toward checkouts of individual systems later in the summer. The major objective for the mission will be to verify the performance of the command and service modules during manned flight. Meanwhile, preparations were intensified for unmanned Apollo missions. For the first flight lunar module, scheduled for an unmanned launch later this year, factory checkout operations were carried out following exhaustive reviews and inspections. Changes and modifications were made to further increase safety and reliability. In late June, integrated systems tests and factory checkouts were completed. The vehicle was prepared for delivery and shipped on June 23rd to the Kennedy Space Center, Florida, on board the Super Guppy aircraft. The primary objective for the unmanned mission is to prove out the lunar module's propulsion systems and structures in the space environment. The lunar module will be launched by an uprated Saturn I, which had already been assembled on the pad at Complex 37, and checkout operations were in progress. Preparations for Apollo Saturn V missions, meanwhile, continued across the nation. At the Marshall Space Flight Center in Huntsville, Alabama, dynamic testing neared completion for Apollo Saturn V. The primary purpose is to prove out the ability of the launch vehicle's guidance and control equipment to function under dynamic conditions like those anticipated for powered flight. The completion of dynamic testing will mark the conclusion of major ground qualification testing for the Saturn V launch vehicle. Also at the Marshall Space Flight Center, a two-day briefing on Saturn V's major systems and design features was held for a number of the astronauts. In the meantime, at the Kennedy Space Center, the first Apollo Saturn V flight vehicle was being prepared for a 1967 unmanned Earth orbital mission. In line with program requirements for hardware reliability, the spacecraft had been removed from the launch vehicle early in the year for an intense review and inspection. During the spring months, the command module underwent rework and modification. After checkout, it was mated with the remainder of the spacecraft in preparation for assembly with the launch vehicle. At the same time, the launch vehicle was being checked out in the vehicle assembly building. As a further check for safety and reliability, the launch vehicle was disassembled for an unscheduled inspection of the second stage weld seams. Even though the stage had successfully passed all previous tests, including static firing, the disassembly and inspection were deemed necessary when surface imperfections were discovered in weld seams in a Saturn V second stage still in manufacturing at North American. It was as a precaution against similar defects that the launch vehicle at the Kennedy Space Center was disassembled and its second stage inspected. As expected, X-ray and dye-penetrant tests revealed that the stage was acceptable for flight, and the launch vehicle was reassembled. This was closely followed by remating of the spacecraft with the launch vehicle. By the end of June, assembly was complete, and the launch crew was proceeding with pre-flight checkout of the entire vehicle. Major objectives of the unmanned missions are to prove out the space vehicle systems and structural integrity during flight, and to verify spacecraft heat shielding during re-entry. Re-entry conditions will approximate those of the lunar mission. There were also significant accomplishments in the preparations for the 3 following Apollo Saturn V flights. At NASA's Mississippi Test Facility, a Saturn V second stage successfully completed a series of 2 acceptance test firings. This stage is a part of the second Saturn V flight vehicle. After acceptance firings, this stage was shipped to the Kennedy Space Center, where it entered pre-flight checkout in the vehicle assembly building, the second of 2 Saturn V vehicles then being checked out in the building. At the McDonnell Douglas Sacramento test site in California, an acceptance test firing was also successfully completed for a Saturn V third stage, a replacement for one destroyed earlier. The new stage will be used for the 3rd Saturn V flight vehicle. The destruction of the earlier stage was traced to the failure of a titanium sphere containing helium. This was the first such failure and the first loss of a 3rd stage. Extensive steps were taken to prevent a recurrence. Manufacturing and testing procedures were made even more stringent. All spheres mounted on flight stages, both Saturn V and uprated Saturn I, were re-inspected. Tests were conducted to verify structural integrity. All this done, McDonnell Douglas proceeded with manufacturing. At the Mississippi Test Facility, the acceptance firing was successfully completed for a first stage of a Saturn V flight vehicle, an event of particular significance because it signified the full activation of the test site. As the Apollo capability continued to develop, activities connected with the investigation of the moon also continued. Langley Research Center, Virginia, under the direction of the Office of Space Sciences and Applications, flew 2 important missions: Lunar Orbiter 4 and Surveyor 3. Lunar Orbiter 4 not only returned photographs of 99% of the Moon's face, but also gave man his most detailed look at the hidden side. "53 hours after this launch from Cape Kennedy, Surveyor 3 landed on the Moon. First bouncing 3 times, it came to rest halfway down the side of a crater 650 feet across and 50 feet deep in the eastern part of Oceanus Procellarum. Surveyor 3 sampled the lunar soil, taking pictures of itself at work. It provided a look at a lunar sunset, indicated by the moving shadows. To help determine rock types, it returned both black and white and color photographs. It was concluded that the lunar surface is lightly cohesive, much like fine-grained granular soil on Earth. With the capability for manned operations in space again developing at full momentum in Apollo, rapid progress continued in Apollo applications, the program for capitalizing on the nation's manned spaceflight capability. A full-scale mock-up of the orbital workshop was evaluated at Marshall Space Flight Center, first by a group of astronauts, then by key personnel from the manned spaceflight centers in a preliminary design review. The astronauts simulated efforts necessary to activate the workshop and perform experiments. The design approach was found to be acceptable. The workshop, built by McDonnell Douglas, is a modified uprated Saturn I second stage. It propels itself into orbit, then after preparation, it can be occupied by a flight crew. Entrance into the stage is gained through an airlock under development by McDonnell Douglas, St. Louis, Missouri. Prime contractor for the Mercury and Gemini spacecraft, McDonnell Douglas is utilizing its manned spaceflight experience in developing the airlock. Also in the program, Apollo telescope mount instruments for investigations of the sun were being designed and development was initiated. For example, a prototype X-ray telescope under development by Marshall was being tested for alignment and stability. And Apollo applications instruments for studying the Earth from space was the subject of a National Academy of Science summer study convened at Woods Hole, Massachusetts. Designed to help man make better use of the Earth's resources, instruments such as camera systems for taking infrared color photographs have been under development for some months. Photographs similar to these infrared color shots, plus many other kinds of data, can be acquired from space and will reveal new facts in fields as diverse as geography and meteorology, agriculture and oceanology. At the end of June 1967, the nation's manned spaceflight program was again moving forward across all fronts, reinforced by a period of intense review and re-evaluation. While the program is even stronger, there is yet much to be done, many problems to be solved. But confidence that our goals in space can be met is growing in parallel with the increasing determination to succeed.